Cool, there's quite a lot more people in here. It is about 2 minutes after, so we'll go ahead and get started. Thanks everybody for coming to the latest scanner spotlight from Digitized Designs. I'm Patrick with Digitized Designs. Today we're going to be looking at the KSCAN-X. This is the latest hardware offering from SCANTECH, one we've been really excited about, and I'm excited to show to you. Yeah, it's handheld, so it's similar in overall form to the predecessors, the previous generation SCANTECH scanners. If you're familiar with the KSCAN Magic or the original KSCAN series, two main cameras, two LED rings. This one has a lot of laser projectors on the front. Usually there's 4 buttons on the back of a SCANTECH scanner. This one has 5. I've also got a little phone mount, basically a threaded hole in the back of here that comes with a magnetic phone mount that you can attach a phone to. It's got a lanyard. You got your usual power and data hookups, and then I've got dual wireless adapters. So this has redundant Wi-Fi capability, so it's stable and very, very fast to be able to stream all the data that it needs to over to the scanning software on your laptop while it's running. So it's still a blue laser scanner, still metrology grade accuracy. This one in particular is 30 microns, just a hair over 1,000th of an inch. If you're used to thinking in inches, this one's intended for, I'd say, small to medium up to large and very large parts, as opposed to the typical or the previous SCANTECH generation, which are very small up to, I'd say, medium large parts, unless you get into the tracker series, like the Nimble Track and the Track Scan. So this is SCANTECH's offering for if you need to go for larger parts, but you don't want the 2-device system of a Nimble Track or like a Track Scan Sharp, for example. It's got 3 laser patterns. You've got the laser crosses that you've seen if you're familiar with other SCANTECH scanners, like the KSCAN Magic or the SimScan, something like that. You've got the single laser line, also similar to those. And those have a field of view about the same as like the Magic 2 of last generation. This one, though, the special thing about this is the ultra large scanning area. They call it like large depth of field mode. That one's got a 2.6 by 1.8 meter width and height of the depth of field, and out to 2.5 meters away from the scanner. So about 0.3 meters out to 2.5 meters. You can visualize how big that field is. And I've got some cool examples behind me here to show you exactly how big that is and how that works. And in that, that's still laser crosses. In this case, instead of the typical 2 sets of laser lines, that pattern is 4 sets of lines, 4 sets of 21 for a total of 84 lasers in that pattern alone. I think if you total that with the other 2 modes, there's over 100 individual lines like this thing's capable of projecting. The previous generation, like the KSCAN Magic, I keep referring back to, I kind of imagine this as the next generation of that. It had a little trigger button here. This one doesn't, because you don't need to shoot individual photos to do what photogrammetry used to do. They still call it photogrammetry in this, but they call it adaptive photogrammetry. If you weren't familiar with that in previous generation scanners, that was where you had to apply, in addition to the targets that you see I've got on and around my parts back here, you also had to throw some scale bars into the field of the scanning field, as well as some coded targets, these square targets that actually have individual numbers on them. And then you'd capture those with an entire extra step beforehand, before your marker acquisition, basically replace your marker acquisition. That would very accurately capture those targets. I mean, the scanner does it accurately on their own, but you get increased volumetric accuracy. So if I need to scan from this hood all the way over to that crate door, for example, I'd get better accuracy if I used photogrammetry. This uses something called adaptive photogrammetry, where it comes with still comes with the scale bars that are on the calibration board, which I've got on that card over there I can show you, but it comes with these special carbon fiber tube scale bars as well, that you don't have to shoot photogrammetry separately. You just place these in the scene, same way you would with the traditional ones. There's 2 of them, and you want to place them not parallel to each other, as far away from parallel as possible. And then so these targets, the coded target in the middle and these 2 sets of 3 targets on the outside, are both visible to the scanner. sometime during your scan. Ideally, if you have a really long, like one really long scan, you want to put these at like the 1/3 and 2/3 spots, just to like maximize their effect on the entire scan. We'll start out without those, but I'll definitely show you those before we finish up. Because that's really cool the way you just do a marker scan just like you're used to. The scanning software just recognizes those, picks them up, and then takes a few more seconds to calculate your marker, your target network that it uses to scan, make sure your volumetric accuracy is really dialed in. So I've talked a lot. I'll share my screen and we'll just get started scanning with this thing. So we'll start off with the simplest. We will start out in the large field of view mode. I consider that to be the primary field of view for this guy. At a millimeter resolution and your default exposure. And I'm going to set up, I mentioned there's a little magnetic phone mount. You might see my computer video chopping in and out for just a second, but because I'm mirroring it over to my phone. Make sure this thing's on here tight, but I can just magnet this little guy to my phone, and now I'm seeing the same screen I'm sharing with you right here on the scanner. I forgot to mention there's also a little, just show you kind of like how this setup looks. There's those 5 buttons I was talking about. I've got my phone is magneted up here. Oh, pulled it out of the clip. There we go. And then there's a tiny little touchscreen interface on the scanner itself that shows you some stats about while you're scanning. So how many targets you have, what kind of exposure setting you're at, all that kind of stuff. It's pretty handy. My settings are set in Define Site. If I did need to change something, I can do a lot more from here. I can decide which of these things that I might want to change, switch target modes and everything. Double check that I'm on that large field of view marker mode. There are 2 different marker scanning modes with this guy. There's near, which is what you'd expect, the closer up field of view, and then there's far field of view, where I can have that full 2.5 meter range away from the scanner. So that's what we set. I'll click the play button and I'll start acquiring those markers. You can see I've got a little green projection. That's something that's new on this generation too, that's showing me about where I'm able to see markers. Zoom out here and get a feel for how large that field of view is. The biggest benefit of that is that means you need fewer markers. SCANTECH does recommend you use these 12 millimeter, the slightly larger diameter markers when you're working in this large field of view mode. But you can see I've got probably 11 of them on this hood. I've got these extras down here on this little fixture, but I'm very certain I could scan this guy without them. I also have a little coded target down here. I have to get a little closer to make sure I pick that up. And that's going to set up a background plane for me automatically before I start acquiring my laser data. So I've got plenty of target acquisition. Press a button on here and jump into the next phase of scanning. I've got my targets. That background plane's automatically been set up where I set that coded target down there, and I'm ready to start laser scanning. It's already, you can see how big that laser pattern is. This is the ultra large field of view mode. So I'm right in the middle of the field of view, and that laser pattern is covering the whole, almost the whole hood. Missing a little in the corner there. I mentioned a 5th button on the back here. So I've got a plus and minus, which will always like let me change my exposure, my zoom. Got a play pause is what let me start scanning. M lets me cycle through some different settings, but this last new button lets me, it's programmable. You can set it to what you like, but I have it set up to currently lock my view on the screen. So instead of you following the scanner around like as usual, I just broke it free from that. And now you can watch one field of view or one viewpoint while I fill in the rest of this. And notice I am picking stuff up on the ground, so I'll snap that view following back on. I'm definitely getting data down there, but it's all getting excluded because of that little target that we left down there. So once we're finished, we can press another button on the scanner to end the scan. But Define Sight is the scanning software we're using here, SCANTECH's latest scanning software. And it'll finish up, do some noise filtering automatically. If there's any stragglers, it works on those. If there's anything left over from noise filtering, we can hit a disconnected components filter and really quickly take care of all of that. So now we're still looking at a point cloud here. Define Sight does have some really cool automation that you can do with, if you know you always want to mesh every single time you're done scanning, you can, in the settings, set it up to when you end a scan from the scanner, it'll automatically run that. So while you're taking the scanner off and setting it down and maybe changing parts or something, it can be taking care of that for you. But we will wrap this, if so, by point cloud, if you're not familiar with that terminology. If we zoom in really close, I've got a bunch of individual points about 1 millimeter apart, which is what that millimeter resolution implied earlier. And I'm going to mesh those by basically connecting the dots between them. SCANTECH calls it wrap as their function that does that. Going to connect the dots between all those individual triangles and make me this polygonal mesh that's, depending on what you're doing, is usually a little bit more useful, a little bit more efficient way of storing the geometry of this part. Still just as accurate as the scanner, that 30 micron accuracy of the hardware, and a little bit more useful for whether you're doing reverse engineering with this or some sort of inspection, anything like that. If we had a CAD model of this guy I wanted to compare it to, you can bring this into a inspection software, or even Define Sight can do that. Bring in a CAD model, align to it, and check the deviation between the two, see how far it is off. If you're just trying to check that they're within 1 millimeter, the whole thing will light up green and you know your part's good, or if it's bad, you'll see exactly where it's high or low, show up in red or blue. Cool, there's our first scan. Let's see, let's hit the motorcycle next. That's one I was really excited to try. We've had this motorcycle here parked for a couple of years, and so it's been scanned with all kinds of stuff various number of times. I was really excited to see how the KSCAN-X did on it. So we'll keep the same resolution. I'm going to tweak some settings because the motorcycle is arguably a lot more difficult of a thing to scan in general than that hood. The hood's not super shiny. It's all one color. It's a nice neutral gray. It's not very dark or very shiny or transparent, which are the three, that's the trifecta of difficult to scan things when you're talking about 3D scanning. Shiny reflects light, funny, dark tends to absorb and doesn't send enough light back to the cameras for this to pick them up. And then transparent, just the light passes straight through it. If it's transparent enough, it's as if it's not there. So the bike has a lot more of that. So I've got to change some settings here to make sure we're going to capture that okay. Namely, we'll bump our exposure up. We'll set this to dark and shiny object. Basically sets a bunch of other settings on the scanner in the background to be ready to capture that type of data. And then we'll start with our, make sure I'm on large marker mode. Yep. Now we're ready to go. So notice we don't have to have just our markers on the part. In this case, I've got some on the ground. I've got these pucks that we've scattered on the ground also. I have another coded target on here, which I need to push in a little closer to capture, but then you can see that it pops up as a little square once it's recognized. And again, that first coded target that you pick up in any scan in Define Sight is going to create a background plane. So I won't have to worry about scanning the floor when I'm working on this. It's also creating a coordinate system there, which is really cool for individual scans. One-offs is not super important, but if you're doing repeat, like for part inspection, for example, where you're going to be scanning 15 of the same part in a row, that can be really helpful. If you put that coded target in the same place relative to the part while you're scanning, that gives you a very close to the exact same coordinate system as the first scan. Pop my phone off here so I can get a larger angle. And that can make repeat inspections go a lot faster. Instead of having to do a manual alignment step, you often can have it be fully automated using that coded target. So if you notice, I've got just 12mm targets on this side. So this bike, as I mentioned, we scan it a lot, and it's set up for just to show a lot of different equipment off. We've got 12mm targets on this side. I've got 6mm on the other. So we can do large field of view on this, the side facing you guys, and then we can use the closer field of view over here with these 6mm targets. But I can capture them all in one go with the large field of view scanning mode. So once that's ready for me, I'll click the, just long press one of the buttons here that kicked me into the next scanning mode, and we're ready to go. So one of the consequences of the dark and shiny mode is your frame rate goes down a little bit. You do have to spend a little more time scanning to get the same data acquisition, but it picks things up in one go that you wouldn't get without that mode on. Like particularly the hardest part of this is weirdly that the red of the tank, and I'm picking that up just fine, even though it's taking me a little bit. I can't move quite as fast as you saw me with the hood, for example. We're picking that up just fine. I think I mentioned I'm wireless. I'm sure you can see I don't have any cables I'm dragging around, but I mentioned the two wireless cards on board the scanner. I've also got batteries. I'll show you. There's a little battery compartment at the bottom here. Stores two batteries, so you can hot swap. You can switch. It only needs one of them at a time, so you can switch one of them without powering the scanner down. And they're just off-the-shelf batteries. There's nothing proprietary about them. So we've been in large laser mode this whole time. If I double tap, I can get to my standard field of view. See how much closer I'm having to get. And here I might not be able to scan because these 12mm targets are spaced for that larger field of view, but I can step behind here and use those 6mm we have back here to do that. So you can mix and match. If you have a large area you need to pick up, but you have a smaller area you might want to capture at higher resolution, you can do both in one scan. You just got to target it up appropriately. You might not be able to see it, but the on there with this crate door that I have over here is set up like that. There's, I think, 12mm targets over the whole thing. So we can capture the whole thing in like 2 passes of the large field of view mode. And then if we want to come back with, there's a small area on it with about 12 of the little 6mm targets on it. We can come back with it and fill that in. So you are limited in resolution with the large field of view mode. You can capture down to 0.5 millimeter resolution. We're at 1 millimeter here. And you can go down to 0.1, which is a little more what you might expect if you're familiar with another SCANTECH scanner with this field of view, the closer field of view. It's still it's generous. It's bigger than the sim scans just because the cameras are a little bit bigger and they're a little further apart. It's a little bit bigger than the KSCAN Magic 2s, I believe. There's still plenty. I don't have hundreds of targets on the other side here that I'm using for this mode. And then lastly, we've got the single laser. This is going to be best for like getting into nooks and crannies and deep crevices. If I want to make sure I get as deeply as possible in one of these areas here, say that little part of this engine is super important to me. That's where I can do that. Focus on something in particular. We'll pause this. Let's see what we've got so far. Check on, don't see. If anybody has any questions, feel free at any time to pop them into the question dialogue there. And I'll see them pop up and we'll answer them either along the way, or we'll definitely have some dedicated time for Q&A at the end. Sweet. So here's what we were able to capture of that bike in just a couple minutes. Notice, just like any of the previous generation SCANTECH scanners, anywhere you have a target, it defaults to deleting a little circle of data right around there, just to make sure you don't scan that target itself. And there's an automated way to fill that in during the wrapping function. If you want that to be filled, there's a checkbox that says fill the hole, and it'll do that automatically. Cool. Yeah, you can kind of see the difference in targets there. There's probably 20 targets on this side. So it's a little smaller area than like the hood that has 10 or 11, but there's more angles I'd want to hit. It's probably why there's a few more targets there compared to this side. You can see probably need about twice as many of the 6mm targets. I didn't really get into why how the scanner works fundamentally. It helps understand why you have to place the targets the way you do. There's the field of view of the scanner, which you've seen how large that is based on me scanning just now. There's the large field of view and the small one. Regardless of which one you're in, the two cameras on the scanner have to see 4 targets in their field of view at any time. The 12mm targets can be seen from a lot further away, which is why they're used in the large field of view scanning mode. And that helps you visualize that green square that you saw the scanner was projecting onto the hood. Basically, anywhere I want to put that green square and I want to expect the scanner to scan, I have to have 4 targets there. And the reason for that is it needs 3 for positioning and then a 4th one to allow like leapfrogging to future locations you want to be. So that's kind of what I'm picturing when I'm targeting stuff up. You might be able to see on the hood, or sorry, the hood, the crate door back here. I've got the 12mm targets. There's about a 3x4 pattern of them, and that's about as far away as you can have them from each other, and still pick up that entire board back there. So same thing applies to the 6mm. That's why the field of view is smaller on the standard field of view mode. You got to get a little bit closer, and you have those 6mm targets closer together, so you have 4 anywhere you might want to scan. Targets can do some other things. You can use them to align between scans. In this case, it's very common when you're using the handheld kind of scanners where you typically have a few targets on your part. It's less common with like the tracker-based ones where the targets you don't have to start with, but you can use them to move the tracker around. As long as you have at least 6 targets, technically 4. I like to say 6 is my rule of thumb to make sure it works. Between 2 different scans, you can use those targets to practically automatically align between the 2 scans very easily. So let's see, let's scan something else. Let's save all of this stuff off real quick. If you're not familiar with Define Site, if you've used SCANTECH before, you've got T-Viewer or Scan Viewer. This is just their newest scanning software, and it's where both T-Viewer and Scan Viewer are kind of coming to that all existing devices will eventually be supported in this. Most of them are at the moment. And yeah, it functions similarly. If you're familiar with one of the other ones, you see the start scanning button and the resolution setting and all of that looks really similar. But it does some cool stuff. One of my favorite things is instead of just the PJ3 file, which would just save the specific scan we're looking at here, I can save a PJ5 file, which is everything in the project that I've got. So if you've got 4 scans, you don't want to have to save them off one by one. You can save that PJ5, it'll save it all into one place. Save that off so I can clear us out here. So let's do, we talked about the adaptive photogrammetry. I'm gonna set that up very quickly and we'll do that. So my 2 scale bars, I'm just gonna place them on the floor here. I have them perpendicular in a plane. It's even better to like get them a little not coplanar. You also come with these also come with these little magnetic clips in the case if you need to like magnet them to a car or something for that example, like something magnetic. Cool. I do have to tell the find site that I'm looking for these two scale bars, or like that I'm putting them in the field of view and to expect them. And then we're ready to go. You might hear a little bit of a beep. There's a little warning beep if you're approaching the end of the field of view in any direction, but you can always turn that off. So notice once I picked up all the targets on one of those scale bars, it lit up with that little line icon in yellow. Same thing will happen over here. There's the first three targets. There's the other three. Got to get in a little closer to see that scale bar. Then once I do that, there we go. So it will actually change color when you scan it from multiple angles. I might have them in a weird spot. Oh, there we go, green. Yeah, if you have them in a weird spot, you don't have to get them green, but if you can, that's better. And then we'll make sure we've got everything else captured. Once this is done, we'll hit that long press my M button again to kick us into the next step. This little waiting period here, it's like 5 or 6 seconds when you're doing just targets. This does take a tiny little bit longer just because it's got a lot of extra math that it's doing to make sure the final like target network that it decides on is accurate to the known lengths of both of those scale bars, and ensuring that volumetric accuracy is good for us. Oh, we got 2 questions while we're waiting on that. I did receive those questions, but this thing's ready. We'll get to those in a few minutes. Just quickly scan this guy again. So notice this one, I did not pick up the individual coded target, and therefore I do not have my background plane going. So I'm picking up the floor. That's really easy to take care of. Disconnected components will probably handle it. If it doesn't, it's a really quick lasso, easy to handle. Cool. So that'll look really similar to the first one. But since we use those scale bars, our volumetric accuracy is higher than the first time. Zoom this out. It's a cool new feature of the Find Site. You can set this to display mode. Let me take out the floor first. We'll do a disconnected components. Highlight the floor, and then display mode will just spin that around for me. So we can answer these couple of questions. So we got, does the resolution / tolerance persist into larger volumes? So I guess larger than what I'm doing here is what I would imagine that means. And the resolution, yes. The tolerance, like accuracy, is similar. There is a stack up. Like the larger you go, the volumetric accuracy does go down at a rate of about 10 microns per meter. I believe that's right. I've got my notes right here. Let me make sure I'm quoting that correctly. Yes. So anything that fits in the field of view is 75 micron volumetric accuracy. And then as you get larger than that at a rate of 10 microns per meter, you add that to the volumetric accuracy. So if something's, an extra 5 meters, you add 50 on top of that there. But the resolution is definitely the same throughout the larger volume. It's whatever you set it to here in define site. The max you can go is 0.5. I think 1.0 is a little more sane resolution for larger things. You get really, the more you space those points together, there's 4 times as many points in a 0.5 millimeter scan than there is in a 1 millimeter scan. And you can really quickly hit scans that are larger than you really need them to be for the resolution you're capturing. Like you can see how much detail we have on this, this hood here, as far as dents and holes. And that's just a millimeter. You can go tighter than that if you need. But if you're just looking for dents, this is more than enough resolution. My rule of thumb for resolution is if you have a feature that's smaller than the resolution number, that's when you probably need to increase your resolution if you need to capture that. It is very commonly conflated with accuracy, and they are not the same. So resolution is just how many points you're capturing, how closely together they're spaced. Those points are still just as accurate as the hardware, like when you combine your local and your volumetric accuracy. So yeah, if you measure 2 features that are large enough to show up at the resolution that you're working on, which is, I'd say, larger than a millimeter at this resolution, you measure between them, that's going to be the same accuracy as if you crank the resolution down, capture many, many more points and on those same features. But the other note on that is if you go large enough, I mean, 1 millimeter resolution is, in this case, we've got, let's see exactly how many points we have on this hood. For example, get rid of the phone screen. There we go. Just a million and change. That's not a ton at all for a SCANTECH scan. I've done stuff up to like 40, 50 million points and higher. But you can imagine this one hood was a million and change. If you needed to do like a full wall or like a whole part of a building or something, you'd capture that many more. And so that's what the biggest thing I keep in mind at really large volumes for resolution is pick a resolution that you can, that will get enough detail, but isn't overly large for the volume that you need to capture. But it's capable of doing plenty. And then what is the maximum target amount that the scanner can acquire? I don't know that there's a hard limit on it. I've definitely never, in any of the documentation or any of talking to SCANTECH engineers, there's never been a number that anybody has mentioned. I personally have had, it was a previous generation scanner and software, but I've gotten close to 3,000 in a single scan. And it definitely took, like the processing steps took a while, and that's just, there's so much data in that. It took a little while to process, but yeah, there was no maximum there. But I will find out if there is a maximum. I know there used to be a maximum number of laser points, like points of scan data that you could capture of 50 million. I believe you can go higher than that in define site, but I also need to confirm that too. It's not common to hit that often. Usually when you're working with scans that big, it's better to break it up into multiple scans, and either if you scan them with the same target file, you scan all of your targets, and you scan a big portion of what you're scanning, save that off, open just the targets and not all the laser data back up. You can keep scanning, adding to that skeleton, and it's putting it all in the same coordinate system, so you can combine it together later. That's a technique that's really common to get around that. So everything I've ever run into, I've never run into an issue that would not allow me to, that I ran out of how many targets I could capture by any means. Cool. Let's see, let me get my phone screen back, and then we can switch over to the hood. Or sorry, I keep calling it a hood. It's the hood for a crate, I suppose, but it's a door. The big piece of wood behind me. So we'll start off the same here. exactly as we have been with 1 millimeter far large field of view marker scanning. I'll make sure I pick up these 6 millimeter targets here also. So I have all my 12s. I'm going to get in a little bit closer to make sure I pick up all those 6s pretty well. And then we'll jump into scanning. We'll do this, scan everything at a millimeter resolution, and then I'll show you a function we haven't looked at yet for that area I targeted up a little more closely. So I was just a little too close there. From this angle. Sweet. So let this start processing. I need to grab my mouse. So what we're going to do here is a function called, it used to be called fine scan, and it's now called multi-resolution. So we captured the whole thing at a millimeter, and I just talked about like how the resolution affects what you're measuring. But say I had something important here. This is all the same, it's just wood grain. But say there's something in this area that I need to capture higher resolution, but everything else a millimeter suffices plenty. I can go into multi-resolution and decide I want to double, quadruple. I'm going to quadruple in this case, what we're doing. And I can circle where I want to up-res my data, hit apply, and then we just jump back into scanning. And it cleared that out, and it's going to let me fill it back up with higher resolution data. Cool, that's all I got to do. And then I'll zoom in on that and kind of show you what that looks like. Hopefully that's also a pretty good example of, if you're not familiar with like resolution in this context, it's a really good practical example of how that works. Yeah, there it is. You can see, it's all got that plywood grain showing everywhere, but then you can see how much more detail you capture. Kind of see the border of it right here. So there's an area with and without, or sorry, with the multi-resolution and without right here. So it's a really cool way to do something large where, say, yeah, you need a big shaft that's several feet long. You need the whole thing just to have that data on the cylinder outside of the shaft, but then you need to get some higher detail on something, the attachment flange on the end, to get the holes a little more crisply. It's a great way to do that. So I mentioned the deleting stuff out of the background. Disconnected components likely would have taken care of that, but I just lassoed it to show you how that works. Do the same thing here on the floor. Cool. There's that guy. We can hit wrap, and that'll be ready for us in just a second. Also, if anybody has any requests for seeing any, like what particularly might you use this scan data for, I'll definitely I'll pick something to show, but if somebody has a specific request, I probably can fulfill that, whether that's like reverse engineering or inspection are the two big ones I would expect. Feel free to pop a question into the Q&A box. Yeah, there's that mesh, and it even meshed with those two resolutions in there, so you can pretty clearly see how that works. There we go. I suppose before I set the scanner down for a minute, I can show you how calibration works, because it is super, super easy. We have the calibrate button. I've got the board already out, but it comes in a little foam insert in the case. It's got these two little doors that you open up. Pull it over so you can see me a little bit better. It's got a little red arrow. I just want that facing away from me. I'll also take my phone off. Put the lanyard on just to be safe. Cool. Position the scanner on top of the board, press the start button. And then I'm the little gray scanner, and the other one is the target I'm trying to aim for. All I got to do is make that scanner, and the cross and the circle all line up. Get the first one. The rest are all in a kind of straight line, straight up. And then there's 1, 2, 3, and 4 angles you have to hit. Then it'll think for a minute. It'll pop up an accuracy number in microns, sorry, in millimeters. So it'll show like 0.0 something millimeters. Cool. So yeah, that's move the decimal place over 3 to go from millimeters to microns. It's at a 3.5 micron accuracy. So this step, I'll skip this one right now. Unless anybody wants to see it, I would be happy to set it up. So this is a secondary calibration step specifically for the largest field of view. There's another couple of boards. You can use anything that's flat and sufficiently white, but it comes with the 4 boards in the box. You can arrange on the floor, and then super even faster than the, why not? I'll just show it. Pull these guys out, put them on the ground. Arrange them into a little rectangle. Just do that one so we can hit skip. And this one's super, super easy. You just point the laser pattern at the middle. And then there's a little distance meter over on the right. I just got to fill up each of those bars. Cool. Close my, see the screen flicker. I'm just taking my phone off of screen mirroring mode. And then I'll pull one of these guys, one of these scans into something to show you what you might do with some of this some of the data stream. I'm not sure if I saved off that hood or not. If not, we can scan that again real quick. I'm trying to keep an eye on the question box too. If anybody has anything, feel free to drop it in there. You know, when you do a multi-resolution scan, there's a lot of extra data that it saves, like almost metadata about the scan. I believe why this is taking a second longer to save on me. Go ahead and get Design X going. If you're not familiar with what Design X is, it's a reverse engineering software. It's a fully fledged CAD modeler, both for solids and surface modeling. It's got all the same tools you'd expect a like major CAD package to have, like sketching and with regards to solid and surface modeling. But on top of those is a whole suite of tools specifically for using scan data to create your models faster and more accurately. Let's see, let me open. This guy, motorcycle, okay. Do a new one super fast. I'll just scan that crate real quick. So as soon as this is ready for me, I'm going to delete any of that straggler information on the ground. We're going to wrap this guy. Save this as a mesh. Bring that mesh over into Design X. And I'm going to show you a super fast way of making this into a solid body that you can use, even though I left a little bit out of that corner. I can clean this up really quickly and get a useful solid out of it. So first thing we'll do is just reduce this. Get down to about, oh, perfect, 40%. So it's about 3.5 million triangles. Reduce that. This is going to do an intelligent kind of reduction. It's going to pull triangles out of areas where it knows it can. Yeah, so anything larger, flatter, you can kind of see that's where the targets got filled in. It was a little smoother. We'll also smooth this just a little bit. Do that decimation one more time. You should see a lot larger triangles pop up. Cool. You can fill any holes. It's warning me I've got some issues in the geometry. I can have the healing wizard take care of all over the area that I kind of that I did not scan thoroughly enough. Let's say we want to fill all a couple of holes in it. We can even do everything except for that largest one. Fill all that up. We can grab this boundary and we can just smooth it out a little bit, make it a little bit easier to deal with. We could even fit a curve to it. It's kind of a advanced, even more advanced smoothing method. I'm going to just chop the end off here. And then last thing I'm going to do, run it through an optimize mesh, just another kind of remeshing. This is my standard auto surfacing like prep workflow. So we're gonna, once we're finished with this step, we'll wrap this with CAD surfaces to make it a solid body. If you brought this into something like SolidWorks, you could look at it, but you really can't interact with it. It's an STL file still. You'll see all the triangles. It'll be real to scale. But if you wanted to use it for anything, can't do much other than look at it usually. So what we're going to do is actually make it a surface. Make sure Healing Wizard says there's no defects. Awesome. We're going to do auto surface. So this little mouse image is going to show you a preview of what I'm going to try to do. Take that mesh, wrap it with surfaces. So it's just showing me what kind of curves it's using. This is why it was really important to smooth the boundary out. The smoother that boundary is, the easier time it has doing this. If I wanted to, I could tweak this stuff, but usually it's really ready to go. And I can hit start. And it's going to result in a surface body. If you have a watertight, a complete volume enclosed with no holes in it, scan, you can get a solid. But in this case, I was expecting a surface since we're working with just surface data. So there's a surface body of that hood. See, it looks a little, if we take off the CAD edges. There we go. So super accurately fit to the scan data. So anything green there is within a millimeter, or sorry, 1/10 of a millimeter. You can go even tighter. I think this little slider here is basically how many spline points it's allowing it to use. You can bump that up a little bit and we can see the accuracy go up in kind. It's just allowed to use more splines so it can fit more accurately. You can see it's even capturing the little details such as those little dents and dings. But this is a CAD body. You could take this and export it as a step, IGES, Parasolid, any of those, and bring it into any of your big CAD packages and use it to design around, or you can modify this, you can punch a hole in it, thicken it, and make it into a solid, anything like that. Cool. I don't see any other questions popping up. If anybody has, feel free to pop them in, but we're approaching the end of our time here. So thank you everybody for attending. That's been the KSCAN Magic Scanner Spotlight from Digitized Designs. If you're interested in taking a closer look at it, you think it might be something that or another 3D scanning solution would be something you'd be interested in taking a look at. That's what we do, pairing people up with the best solutions for their things, and we'd be happy to talk to you. So feel free to reach out. We'd be happy to do a demo or chat with you further. If nobody has any other questions, I don't think I see any. We'll wrap it up there. So thanks everybody. Have a great rest of your day.